back in, I think it was section 2 or 3 or something, we talked about E, okay? And we talked about earlier that if you take some like 10 to the something power, it's the anti-log, so log and 10 to the whatever power cancel each other out. So in this case, we're talking about E and natural log. Natural log cancels out E, they're opposites. Okay? So it says, often when you solve problems involving the number E, it's best to use logarithms to the base E. These are called natural logarithms.
What is E do again? What does E do again?
E is usually used as a base, like E to the power. It's usually used as a base. It's the 2.17.
1.281828.
Okay, E comes up a lot in calculus and in other things, because E, they call it a natural logarithm because E is like a naturally occurring number. Remember that was, if we took 1 over 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3, and we just kept going and adding all those fractions together to get closer and closer to E. That's why it's called natural, because it's naturally occurring. Okay, example 1. So rumors often spread quickly through a group of people as one person hears something and then tells other people about it, who in turn tell more people. Sociologists studying a group of people determine that the fraction of people in the group P who have heard a rumor after T number of days can be represented by this equation. The net equation. Oh yeah, that's the whole sociology. That's the study of people and how they interact. There's a whole field of that. Like, psychology is studying how you think, sociology is how you interact. Oh yeah. It's a science, all sciences are about. So in this equation, P sub 0, remember that's like the initial starting point, so it's the fraction of people who heard the rumor at time of 0. So it's who starts it, who knows it, where the rumor starts. They're usually the ones that start the rumor. Okay? And then K is just a constant, which usually they either give you or you have to find. In a particular study, sociologists determined that at time of 0, 5% of the people in a group have heard a certain rumor. After 2 days, 25% of the people in the group had heard the rumor. And how long will it take for 80% to hear the rumor? Okay, so in this case, what we have to do first, we have to figure out what K is. That was weird. So we have to figure out what K is because they don't give it to us. However, we do know at type T that 5% of the people have heard the rumor. So 5% would be our P sub 0.
What's the P?
What's the P?
It's like the P.
P equals this P. P is the number who have heard a rumor after T amount of days. So that's what we're also saying.
Timber.
This is what we're ultimately looking for. We're going to figure out, that would be our 80% to figure out at time T. Because if we were going to plug in what we know so far, 80% of the people to hear the rumor, that would be our P. So we would write it like this. We're going to kind of be working backwards. We know P sub 0 is 5%, but we don't know K, and we're looking for T. So in this case, 5 or 25?
I thought P was a number.
5. P is a number, yeah.
Like actual number.
Well, they don't tell us how many people are in the group, so they just say 80% of the group. So we're going to have to figure out what K is first.
Project use 25.
At all. Well, because that's after 2 days. In this case,
Is that we're going to kind of T, K, I mean, splitting 2 for T and for.
I would say, okay, P sub 0 stays the same no matter what. That's our starting point. That's 5% of our people, right? P, in this case, if we're using this information, P is going to be 25% because that's at time 2 days. And we can figure out what K is using that information.
I thought P was 80%.
That's where we're ultimately looking for, yes. But in this case, in order to figure out that, we need to know what k is first, because we're looking for t, because we're looking for how long. So in that case, with the information they give us, we can't figure that out yet.
I thought T was 2 days.
T is 2 days with 25%. We want to know what day is it with 80%. That's what we're looking for. So we want to
Guess.
Figure that
now
out.
we can just guess.
So it's around 7 days.
Yeah.
25.
No. Okay, so in this case, I would rewrite. So in this case, P is going to be 25%. Okay? You don't have to rewrite, it's fine. Okay? P to 0 is still 5%. E to the, we don't know what K is, but time is T. So I can say 2 times K. Over 1 minus 5% is still a P sub 0 times 1 minus e to the kt, and t is 2. So we have 2 times k, which is what we don't know. So first we're looking for k. All right, everybody good so far? Yep.
We have to worry about this in our assignment.
Well, there's short problems here, so I
Will they do this hard?
not quite this one. This is the hardest one that we'll do. All right, so what I would do first is I would simplify this denominator by first multiplying through, distributing through, and if it helps, if we're working with decimals instead of percents, making sure to change everything to a decimal here. So 1 minus 1 times 5% is 0.05 minus 0.05 e to the 2k. So all we do is distribute through.
So what is it? Are we done with that first problem?
With this one?
Yeah.
No, we're going to come back to it. Once we use this one to figure out what k is, we're going to go back in and plug in so we can figure out what t is. Because that's what we're trying to find. This time is it on 80% of the people know what we're. All right, so looking at what I have so far in blue here, how can I simplify it even further?
Can you cancel?
Nope. Good job.
Or do 1 minus 0.05 minus, no, just that.
Yeah. What would we get? What would we do?
And then you can cancel out the E to, and you can cancel out the point E to K.
No, you can't cancel it out because we're subtracting. If we were multiplying, then yes, but otherwise, since we're subtracting, then we cannot cancel it out.
Yeah, can we take the 105 out?
Can you take the 0.05 out? You mean like factor out?
No, not canceling something.
Like cross cancel here? No, because we're subtracting. Can you
But we can take it out of 0.95 and
okay, sure.
Can you take 0.95 minus 0.05?
No, because they're not like terms and stuff like that. Let's get it done.
Do something with 0.5.
we can reduce.
We could reduce.
So it'd be only,
Subtract.
it'd be
That gets
1.
better.
No, subtract 0.05.
Okay, if we divide it out of everything, yes. So what's 0.095 divided by 25?
505.
0.505? Okay.
It's
We
one,
put decimal in it.
it's 1 over 19.
1 over 19? I don't have a fraction. So let's just leave it.
No, you know, so it'd be e to the 2k
19.
over 19 minus e2.
You just make it harder to do it that way.
Okay, can you just
Let's make it clear. All right, so since we have a fraction, and we don't really want to work with fractions because, yeah, they're yucky, I would just multiply by the denominator on both sides, because if we multiply with the denominator, then it's up there.
That's what I was supposed to say.
Oh, I'm sorry. I know that's what
But I did the top one instead of the bottom one.
It's close. All right, so if we multiply the top and the bottom, sorry, both sides of y, the denominator, and the fractions go on the right side, we're just multiplying there on the f. So then I'm going to distribute through. I think this is a 0.2375. Should be a plus because this is a minus times a minus. That should be a plus then. So all 1 to I. Okay. So now we've got e to the 2k and e to the 2k.
Then you just give it a look.
No, you can't just get rid
Can't
of
start with it.
okay, here's one thing. Think of the e to the 2k as just saying an x. It was the whole thing, this whole unit was an x, and this whole thing was an x. What do you do?
Subtract 0.2375.
No.
Subtract 0.0125 e2k.
Yeah, because they're both e to the 2k, so we can put them together in our like term. So over here on the left is this. 0.05 minus that guy gets us 0.0375. E to the 2k.
Then you divide.
Yep.
You get 6.3.
6.3.
Repeating.
Why? What's that little thing?
Repeat.
Well, I know what's the one below? Right next. Right next to E. What's that?
2k
No.
equals.
Oh, yeah. It looks like a dot with a
Oh,
line.
Okay, so now once you get e to the something exponent all by itself on one side of the equal sign, and there's no like coefficient in front of it, there's no adding subtraction with it. Now we can get rid of the e by taking a natural log of both sides.
How do you take that? Is that LN?
Yep,
And they do it in L.
I don't know. Because that's the way they do it. I want
So I got this
to
L thing or something.
Alright, so when you take a natural log of an e, remember they cancel each other out. So this is just left with 2k e equals the natural log of 6.3 repeating. So then you can get k by itself by dividing by 2.
So the natural log of 6.3.
Well, no, not 6.3, but 6 and a third. Because 0.3 repeating is a third. Don't round.
So 6.2, just try to have to read it.
As long as you go all the way across your calculator, you'll get pretty close.
6K is like 20.
So 6.
So k 2k turns into a regular number.
So is
There's
there
your teacher regular number. Yeah, because we're taking a natural log of this, divided by 2, just plug it in your calculator.
I don't think I got this right. I got 0.9.
Yeah.
So okay, we're gonna go through all the decimals on your Okay, so 0.922913345 is what I can write now. You got it?
Close enough. 0.9.
0.922913345.
How many decimals should we have?
As many decimals are on the calculator.
That's a smart thing, God.
1,
Because we don't want to round too
4,
early.
5, 2.
I can't find. My calculator didn't quite go that
Mine did. Well, that's mine did.
Okay, so we're not quite done. This is like halfway through a problem. So we're gonna know what k is, but what are they asking us to do?
Quit.
They ask us to find.
After 2 days. How long will it take for 80%?
Yeah. Okay, so here's what we started with.
So we do the same process all over again?
No, plug in. Not quite. We're gonna plug it. We're gonna plug in k up here. Yep. right here, and right here.
It's the same process.
It's not the same process. It's not like
We're using T instead of K.
it's not quite as bad. Okay, so we've got 80% equals 0.05 e to the big long decimal, which is k, times t this time.
Times T.
Times t, because we're looking for t because we know what k is now. We're looking for time.
I thought we knew.
You know
That T was 2.
No. T is 2 when there's, what was it? When 25%. We're trying to figure out when it's 80%.
This is
I'm sorry. 1 minus e to the big long decimal.
We just keep investigating until we figure
As long as you remember to put it back in. So, yeah, basically the same process as what we just did. So I would distribute through and then simplify. So it comes up to the same idea as what we did before, right? So we're going to multiply again. So
just
really-
fast forward.
No, we can just fast forward. No, but we can look back up here to what we did earlier because the denominator has not changed except for our exponent here. So we can take this part, it's going to be the same, except instead of a 2k, it's going to be this big long decimal.
And instead of 0.25, it's like going to be 0.80 now. Because
Yes. Yep, so this is going to change to 0.80, but all this other stuff is the same, except for instead of 2k, it's going to be big long decimal t.
You saw the
That's fast forward.
Okay, sure. All right, what's the only thing that's changed
from one.
from this, from here, is instead of 0.25, it's 0.80, right? And instead of 2k, we have the big long decimal t. So we're doing exactly the same process.
But we don't
That's
put
what we did already.
but we don't put 2 there anymore. Or do we? We're 2K.
Right, we don't put 2k, we put big long decimal t. So we can just copy down from here. So we'll have 0.80 times 195 plus 145. Use the big long decimal. T equals 0.05 e to the big long decimal. Okay, so then we can distribute through like we did before, right? So we're going to have 9.6 or 76 and 0.04. So we've got E over here and E over here. What are you going to do now?
Natural.
I'm going to divide. I'm going to do minus. Minus. Yep, so we're going to subtract this guy. So then we have 0.01 e to the big one thing. All right. Now what do we do? Trying to get e by itself. You're going to do no. But yeah. So then we have. So just have this 76. That's what I've got. Okay. All right, now it use by itself. Now what? Now natural log. So natural log log cancels out, so it's just left with the exponent.
divided by 0.9.
Yep. So that cancels, so t time is natural log. And like these we did with the earlier with the logs, we want to just go to 4 decimals.
4.692.
Oh, that's 7 days.
No, because we're going to go to 4 decimals.
6925.
Because with logs, that we're doing logs, one of the places to be as accurate as we can. Yes.
Then we have those items.
No, it's not. It's in days. So it's like days and hours. And nights.
You want anything like that? Was that?
Just take it
I like something like that.
It's like, come on.
Okay, let's start the next one. This one's a whole other chapter. Alright, it asks us to convert it to a natural log and to evaluate it. So basically what we're going to do is the same thing as what we did before when we had the change of base, where we changed it so it was base 10. Well, in this case, we're just changing it to a natural logarithm, which is a base e. So you could write it as log base e of the big number divided by log of base e of the original base. But instead of writing log base e, you can just write it natural logarithm because that's what it is. Over natural logarithm of 6, and then just have a new number. Basically.
I thought so long with use natural log.
Yep, log of e is natural log. Just like the common logs was a log base 10. This is the natural log of base e. So I have 3.0904. Okay, with this one, when you have a natural log, just like before when we wanted to get the natural or the logs by themselves, we had their calculator, same idea. So we want to get this guy by itself. What are you going to do first?
Minus plus 16, like you got over the second.
No. Okay, treat the natural log of x like it's just a variable, it's a y. So I have negative 16.25 times y, and I get rid of the negative 16.
No, that's right.
Okay, so then we end up with negative 0.4. So I got rid of that anyway.
Divided by.
Divide by what? In this case, since we've got a natural log, and we're looking for this guy, we're going to take each side to the e. So we're going to say e to the negative 0.4 and e to the natural log of x. But what happens with an e and the natural log? They cancel. So the right side, we're just left with x is equal to e to the negative 0.4. And you can check that in your calculator. E is usually a second order shift from natural log. Six, 7, 3. Okay. An example for us is solve each equation in log by using natural logarithms. So we're going to do exactly the same steps as what we did before when we did like the common logs, but instead of logs, we're just going to write natural log. So like with this one, since we've got exponents with variables, we're just going to say natural log of each side.
Why would you use natural log?
Because it says using natural logs. She's having.
Oh, wait.
But if we bring it along, we'll get the same answer.
You should, but you're still going to kind of wrong. It says use natural law.
What did you do with the 7?
Oh, it should be.
Asking me this.
Sorry. Alright, so then we do exactly the same thing that we did before. What are we going to do now?
Can you add an E?
Not yet. Oh.
Here, go.
We're gonna do E when we have one natural log always, so one second on one side.
That's when you can do it.
That's what we can do. Yep. What do we do with those exponents right now? Oh, come on, we just did this. On the worksheet.
Let's see. Do the exponents.
Move them out.
Or to the outside. Multiply. Okay, now we're good. What can we do on that right side? Come on, you know this. Distribute through, right? Okay, we got an X over here and an X over here. What are we gonna do? Move them over, put them together, yeah, so we're gonna subtract this guy over. So we'll have 2x natural log 3 minus x natural log 7 equals negative x. Alright, we've got two x's. They're not like terms, we cannot put them together. Now what? No, it.
So you have done that a little bit.
This is a natural log 3, that's a 7. You can't put them together because they're not like terms.
You move the sevens together.
Nope. Because that would just be undoing what we just did.
Put the X's more together.
Elaborate on that.
You squish them together.
I don't know.
It's not a technical term.
Divide by something.
You put glue together.
And we, on the outside, right? Undistribute, factor out.
Yeah.
What are we left with in the parentheses?
Sure, why not? 2, 1, 3, or
Yep, natural log 3, yep.
3 minus 2 natural 7.
Okay, now what?
You move over.
Move it over now.
Divide.
Divide. Okay, then you just have everything in your calculator. Make sure you put the denominator in parentheses so your calculator knows that you're divided by that whole thing. We don't even have to use an E in this case. Not like E's.
I just got confused. Why is that supposed to be a 7?
Where?
Natural. Below.
Oh, right here, yes.
And below.
So I come up with negative 7.742. With these, it's is nice because you can check your answer easily if you just take x and put it back in up here in your original problem and make sure that 3 to the 2 times whatever that decimal is equals the same as 7 to the decimal minus 1. It should. Okay, 7.79. Alright, let's look at B. We got variables in a exponent.
Oh, wait, next one is the next one.
Oh, what are you gonna do?
Bring them down.
How do you bring them down before you do that?
Well, maybe natural log of 6x2 minus 2.
Yep. And the natural log over here, because you have to take natural log on both sides. Then we can do what? We can do an E. Oh no.
Bring down the x.
That's one. Good. Bring that there. And one.
Divide by ln 6.
Good.
One half to
And have to, so maybe there's right itself, yeah.
the square root of
Alright, so one, we work towards a closer. It's
Why is that question?
because we got a squared. Remember with a squared, we can do either or. Alright, don't know the definitive density, but we're missing minus 6
I'll see who they are and see if I can pursue them somehow. But maybe ask, do you see any more there? No? Okay, all right, thanks.
Yep.
Okay, so you will want to get kind of fast.
Okay, we're gonna do.
Like right where it says, what do you divide by 6?
Oh, so it's a change.
Okay.
I know.
Okay, right, it's not that bad.
So you divide by 6.
Divide by natural log 6, because we're multiplying here. We got x by itself, so we're gonna divide, right?
Yeah.
Okay, so we've got this.
Mm-hmm.
So then we're just gonna add 2. And then we take the square root to get rid of this guy.
Then what? So we have to take both the negatives,
Both are the negative.
positive and negative.
Yes, we need a
But I
positive.
think we could have negative natural logs.
So, but it's not, because we've got it as an exponent, it's not a natural log. We're not taking a natural log of negative 48 or anything. It's okay, because it's an exponent. No more good in the book here. Hang on, don't leave. Go write your task. Thank you. Oh, it's gotten worse.
Oh, right.
18.
No, it wasn't too bad earlier, and that was